Alright, in this video we're going to be working with exponent rules where our exponents are all integers, and in later lessons we'll work with exponents that are rational exponents, in other words fractional exponents. So in this video we'll start with a set of rules here. So we'll use B for the base and we'll use P and Q for the exponent. So the first rule, notice we're multiplying like bases here, so we're going to be adding their exponents, so that would be equal to the same base with the exponents added. Okay, so that's P plus Q there. Next rule, we have base B raised to the power of P, all inside parentheses, and that whole thing raised to the Q power, so outside to inside we actually multiply those exponents, so that's equal to the base raised to the power of P times Q. So outside to inside we multiply. Next one, we have base B, and notice the bases have to be the same for this to work. So base B, the base raised to the P power divided by the base raised to the Q power will actually subtract those exponents, so that's equal to B raised to the P minus Q power. Alright, and next one, if we have the base B raised to the negative P power, so we have a negative exponent, that's equivalent to 1 over that same base raised to the positive P power. So if you have a negative exponent, if it's in the numerator, you move it to the denominator and make it positive. If it's in the denominator, you move it to the numerator and make it positive. So for example, off to the side here, if we had 1 over B to the negative P power, we would just take this base with its exponent up to the numerator and make it positive, so that would be equivalent to the base raised to the power of P. So we're just taking this and moving it up to the numerator, so it would be over 1 and it would end like this. So that rule is the same as this. It just depends on where the negative exponent is. And the last one is anything raised to the 0 power, so any base raised to the 0 power is equal to 1 except 0. Except 0 cannot be equal to the base. The base cannot be 0, in other words. This base right here cannot be 0. 0 to the 0 power is undefined. Anything else to the 0 power is equal to 1. So that's it for the rules. Let's look at some examples. Okay, this first one here is super easy. 137 to the 0 power. Anything to the 0 power is equal to 1. So that one's done. Next one, 3/4 raised to the negative 2 power. So I'm going to rewrite that with a horizontal fraction bar so we can see what's going on. So there is a shortcut for this rule. If you raise a fraction to a negative exponent, you can just take the reciprocal of that fraction and raise it to that positive exponent. So change the sign of the exponent, take the reciprocal, so the 4 comes on top, 3 comes on bottom. So that gives us 16 over 9. 4 squared is 16, 3 squared is 9. It is the same thing as doing this. You bring the negative 2 exponent into the numerator and denominator, so you end with this. Well, then you end up applying the negative exponent rule. So the 4 to the negative 2 comes on top as 4 to the positive 2. You just bring the whole thing up top, make the exponent positive, and then the 3 to the negative 2 power is going to come down to the denominator and make its exponent positive. So notice this is the same as this. So you get the same answer, 16 over 9, either way, but the shortcut is you raise a fraction to a negative exponent, you take the reciprocal and make the exponent positive in both the numerator and denominator. Alright, let's move on to the next examples. Okay, example 3 here, we're raising negative 1 to the 2001st power. So the rule is if you raise a negative number to an odd power, the final answer is negative, so in this case it would be negative 1. If we raise negative 1 to the 2000 or 2002nd power, so it was an even power, it would flip the answer to positive 1. So you raise a negative number to an odd power, the result is negative. You raise a negative number to an even power, the result will be positive. Alright, example 4. So we have essentially this, 3 to the 1st times 3 squared. That's what we have. That's equivalent to this. So we're multiplying like bases. We add their exponents, so 3 to the 1 plus 2 is 3 cubed. We just add that 1 and that 2, And this is something we can simplify. 3 cubed is just 27, and we'll use this as our answer. If we had 3 to the 27th power, for example, or 3 to the 40th power, we would leave it 3 to the 40th power because that would be a huge number. But when the number's reasonable, write it out like this. All right, example 5. We need to be careful here because this negative right here is out in front, and it's different than this right here. Okay, that is not what we have. We have it just as it's written. So we're going to redo this like this: -1 times 2 to the 5th power, because that negative we have to be careful with. If the -2 is in parentheses, then the negative would also be raised to the 5th power, but it's actually not the way that it's written. So you have to be careful with that. So 2 to the 5th is 32, and then the negative of that would be -32. 2 to the 5th is 32. You still have to multiply that by -1. So be careful with whether or not the -2 part is in parentheses or not. It will yield a, in this case it would be the same, but it can be different, especially if it's raised to an even power. So just be careful with those negatives when you're working with exponents. Alright, now for example 6. So you notice we have a base of 4 here, we have a base of 8 here, we have a base of 64 here. In order to work with our exponent rules, we need all the same base. And 4, 8, and 64 can be rewritten with a base of 2. And we're not using a calculator in this unit, but we will have, and you'll eventually get most of these down, but we will have this power chart to work with. So notice that 64 is 2 to the 6th, 16 is 2 to the 4th, and 8, 2 cubed, 4, 2 squared. You know most of these smaller ones, but for example, you might not automatically know that off the top of your head that 64 is 2 to the 6th, but it is. So that's what we're going to start with. So we're going to rewrite each of these bases, the base of 4, the base of 8, the base of 64, as with a base of 2 instead. So 4 is the same thing as 2 squared, and then that is cubed, so that represents this section right here. 8 is the same thing as 2 cubed, and that's raised to the 4th power, so this right here is equivalent to this. 8 is the same thing as 2 cubed, and it's raised to the 4th power, all over. 64 is the same thing as 2 to the 6th power. We saw that in that power chart before, and then that's raised to the -2 power. So then the next step, we use our outside to inside rule, so these exponents here, here, and here will be multiplied. So we get 2 to the 6th times 2 to the 12th. So this is 2 to the 6th, 2 to the 12th, all over 2 to the -12. Alright, that's this 6 times -2. So then we can use our negative exponent rule and bring this to the top, so we no longer have a denominator. So that's 2 to the 6th times 2 to the 12th times 2 to the +12. We just take this, move it on top, make the exponent positive. And now we just add all of those exponents up. So 12 plus 12, 24, plus 6, 30. So the final answer is 2 to the 30th power, and that would be our answer. In this case, you would leave it 2 to the 30th power. We wouldn't want to work that out and write it as one huge number. Just leave that one 2 to the 30th power. Okay, we'll look at one from your homework also. We're going to look at number 14 from your homework next. Okay, this is number 14 from your homework, and we're asked to simplify these. So the first thing we want to do is handle these negative exponents. So this part right here, notice the 11 is not raised to the -2 power, only the x is. So that becomes 11 over x squared. We're just applying our negative exponent rule and taking this down in the denominator, and there is no denominator to begin with, so we have to take it down and make this into its own little fraction. This section right here, same thing as this. So it's in the larger numerator still up here, okay? It's not taking this down here. That's not what we did. Alright, and then minus 3x to the 4th, that stays the same. So that's the new numerator after we applied the negative exponent rule. And then down here we're going to do the same thing. So x to the -1 is going down in the denominator here. So 3 over x to the first power, or just 3 over x. Okay, now we have a complex fraction. And earlier in the year, we worked with complex fractions. One way that you can get rid of a complex fraction is multiply every term by something that would get rid of the smaller fractions within. So we have this smaller fraction and this smaller fraction within the larger big fraction. That's what a complex fraction is. So we want to get rid of this x squared and this x so that there are no longer these mini fractions within the larger problem here. So what we can do is multiply every term by x squared. So we're going to multiply everything, top and bottom, by x squared. X squared over x squared is 1, so it's still okay to do. As long as you multiply every term by the same thing, it's fine. So we're going to multiply that by x squared. That will then cancel that. So we're left with, we'll do this. So we're left with 11 right there. That's all that's left because this x squared will cancel when we multiply it. We multiply this by x squared, and we have negative 3x to the 4th times x squared, so we add those exponents, negative 3x to the 6th power over. Now we're going to multiply this by x squared, and that square cancels with that x, so we're just left with 3x in that spot. So we have 3x on the bottom. And there's nothing else we can do to that one. 11 minus 3x to the 6th all over 3x. We can't do any more, so that would be our final answer. There are no other exponent rules we can apply. Make sure that you don't try to cancel this 3 with this 3, because we don't have that situation. The 3x is the denominator for this whole quantity right here. So we cannot cancel that 3 with that 3. Okay, make sure you understand that. So that would be our final answer on number 14. 11 minus 3x to the 6th all over 3x. And that's it for this video.